All right, so today we're going to be talking about trigonometric functions. And so hopefully you remember from geometry and last year that we have the thing that's called SOHCAHTOA. So sine is going to be your opposite over your hypotenuse. Cosine is your adjacent over hypotenuse, and tangent is opposite over adjacent. And last year you should have also learned about your cosecant, secant, and cotangent. They are the reciprocals. That means flipped. Doesn't mean like this button in your calculator. Don't use that. Does not mean cosecant. It's the reciprocal, meaning flip it. So this becomes h over O, h over A, and A over O. And then just a little refresher in case you have forgotten this. If here's my angle, then across from the right angle is always called my opposite, or always called my hypotenuse. And then the other angle that makes it up. So this is the other leg that touches it. So here's the hypotenuse. The other leg that touches my angle is called the adjacent. So this leg touches it. And then the one that's straight across from it is called your opposite over there. And it will change depending on which angle we're looking at. So make sure you pay attention. So right here, everything's already filled out for you, so you don't have to find anything. So all we need to do is label. So across from my right angle is called my hypotenuse. The other side that touches my angle is right here. So that's called the adjacent, which makes my 12 my opposite. So now we need to make sure, and you need to make sure you put sine of your angle equals, because it is sine of an angle. It's not sine in a fraction. It's not sine equals. It's sine of an angle equals. So sine equals O over H. Cosine equals A over your H. And then tangent is O over your A. And then I'm going to do my reciprocals for the other ones. So cosecant of my theta, secant of theta, and cotangent of my theta. So you're just flipping. So this becomes 13/12, 13/5, and 5/12. So right here, everything again is already found for us. So go ahead and label all yourself. So across from my right angle, I'm going to label as H. My other side touching is called A. So this was the H. So the other side that touches my angle is called your A. And this is your opposite. So I'm going to go ahead and write out my trig functions: sine, cosine, and tangent. So sine equals OA, so 4 over 8. 4 over 4 square root of 5. Cosine is AH, so 8 over 4 radical 5. And tangent is OA, so 4 over 8. So if you want to go ahead and reduce these, this really is 1 over radical 5. This is going to be 2 over radical 5, and this is going to be 1/2. There are some people who want you to get the square root off the bottom, like the ACT. So for my class, I don't care. Leave the square root on the bottom. Maybe on some of the delta math, they might make you. So remember, you just multiply top and bottom by square root of 5 over square root of 5 here. So really, this is going to give you square root of 5 over 5. This would give you 2 square root of 5 over 5, and then 1/2 is still the same. What's nice is that when you do the reciprocals, you use the original because it's way easier to flip those. Let's see, secant of theta and cotangent of theta. So cosecant would be square root of 5. This would be radical 5 over 2, and this would just be 2. So down here, I'm missing one of my sides. So if I do the a squared plus b squared equals c squared, so you would do 6 squared plus 6 radical 3 squared. And then you need to square that number. So I'm going to hit second square root of that answer, and we get 12. So your hypotenuse here is 12. So that's your hypotenuse, which makes the 6 adjacent, and this is going to be your opposite. So sine is OH, so 6 radical 3 over 12, AH, then OA. So reducing this, I get radical 3 over 2, I get 1/2, and this would be 1 over radical 3. If you wanted to rationalize this denominator, it would become radical 3 over 3. And then your other ones, cosecant of theta, secant of theta, and then cotangent of theta. So flipping this gives me 2 over radical 3. Again, if somebody wants you to rationalize that, it becomes 2 radical 3 over 3. I'm fine unrationalized. Flipping the 2, and then this would be radical 3. Flip the 1 before you rationalized it. So right here, now what you're going to do is you're going to have to draw your triangle yourself for this problem. So I'm just going to make that my angle right there. So from my angle, remember tangent is OA. So opposite of this angle has to be the 7, and the adjacent has to be 24. And then you'd use Pythagorean theorem, a squared plus b squared equals c squared. And I get 25 for my hypotenuse. And then we're just going to write out all of our stuff. So I'm going to put tangent back in here, even though tangent was already found. The sine is OH, AH. And then we're going to do this with 7/24. Okay. So down here, remember cosecant is H over O, because that's sine's reciprocal. So just draw yourself a fancy little triangle, label an angle. So H is 37, O is going to be 12. If you use Pythagorean theorem, you should find your missing side is 35 over here. So this is H. Oh, wait, why did I do that wrong? O is here. And this is 35 here, adjacent. Sorry, it's a long morning already. Sine, cosine, tangent. So sine's going to give me 12 over 37, 35 over 37. $12 over 35. All right, so this is a 4/1. So secant is H over A. So I'm just going to set up this triangle, and then we'll move on to the back. So H has to be 4. That makes my A here 1. So using Pythagorean theorem, so that'd be 16 equals 1 squared plus A squared. So this is square root of 15 over here. All right, now to solve right triangles. So solve each right triangle around all of them to the nearest 10th. So we're just going to figure out what is missing and figure them out. So if this is 72, to find your other angle, you're going to have 180 minus your 90 minus your 72. So that gives me angle B. So angle B equals 18 degrees. Now I need to figure out the lengths. So if this is big A, this is little a. And the way I also remember is this goes B and C, so little a is missing. It's A and B, so little c is missing. A and C, so little tiny b is missing here. So that's also how you can label this stuff. So I'm going to find little c first. So to find little c, I'm going to say that this right here, my angle, I have adjacent to my angle, and I have the hypotenuse, so that's cosine. So cosine of 72 equals A, which is 15, over H, which is my C. And then you just cross multiply these two. So cross multiply it, I'm going to get C times cosine of 72 equals 15. So we're going to end up having to divide this time to get that cosine of 72. So we get 15 divided by cosine of 72. Let me make sure I'm in degrees because I teach calculus, so I was in radians. So then little c is going to equal 48.54. This is also called side AB if you want to label it like that instead too. And then you have two options to find little a. So we could set up another trig function that would be tangent. So I'm going to say tangent of 72 would equal a over 15. This time when I cross multiply, I get a by itself. 15 times tangent of 72. So 15 times tangent of 72. So I got little a is 46.17, and that would be also called CB. What you could have also done, though, is use Pythagorean theorem. So if I used this decimal up here as the one side, so that was my C. So I'm going to square that. I'm going to subtract 15 squared because we're trying to find the side length. That's why you subtract. And then I'm going to square root that. And I also get 46.16. So you can use Pythagorean theorem to find your other side, or you can just set up another trig function like I did down here and find your missing side. All right, so up here, angle R is going to equal 56 degrees. Same thing, 180 minus 90 minus 34. So let's see, this is my H. So this is my A, and that's my O. So let's go ahead and find, so this is little r, little s, and little t. So I'm going to go ahead and find little r first, so that's adjacent. So I'm going to have cosine of 34 equals r over 42. So this time when I cross multiply, I get r all by itself. So I'm going to get 42 times cosine of 34. So 34.8. So little r is 34.82. And then if you want to find little a, you could do sine of 34 equals s over 42. Or you could do Pythagorean theorem. I like this one because it's a lot less steps, but it's totally fine to do the other one too, because I know that makes a lot more sense to some of you guys. So little s is 23.49. All right, down here, this I'm given no angles at all. All I'm given length. So first thing I'm going to do here is to find my missing side. So the missing side down here would be little k. So I'm just going to do Pythagorean theorem real quick, because that will be easier. So this is going to be subtract, and then square root that number. So k is going to be about 2.5, because it'll be 498. So when I type in my calculator, though, I'll probably use 2.498 just so I get a pretty good accurate answer for it if I needed to. So these right here to get k, I'm going to go ahead and use the actual numbers that were given. So to find angle k, this is your hypotenuse, and this would be called my adjacent. So to find that, a and h would be cosine of k would equal a over h. So to find angle k, you're going to be doing cosine inverse of that fraction. So that's when you now do that second cosine button in your calculator, 7.6 divided by 8. So we get 18.19. So angle k is about 18.19 degrees. And so then I can find my other angle L by subtracting it from 180. So we're going to have 90 minus, because that's how much is going to be left. So it's going to be 71.81 degrees. So over here, same thing. Let's do Pythagorean theorem. So a squared plus b squared equals my c squared. So little e is about 30.78. And now let's find, so I'm going to find angle F. So that'd be opposite and adjacent what is given to angle F. So let's see, that would be sine of F equals A over H, or A over A. Oh, yep, that's wrong, because that would be A over H. Don't listen to me. That's going to be tangent. Tangent of F equals A over A. That's tan inverse that. So I get 43.03, we'll say. So angle F is about 43.03 degrees. And so that gives me angle D is about 46.96 degrees.